Okay, so we already know how to solve quadratic equations by factoring. We know how to solve for the zeros by by using zero product property and by using quadratic formula. Today we are going to complete the square, and in order to do that, we need to find what the missing square is. So in order to find the missing square, this is the formula we're going to use, which is C equals parentheses B over 2 parentheses squared. The B over 2 is in parentheses because that entire fraction will be squared. So we don't want any confusion that thinking just the B is squared or just the 2 is squared. That entire thing will be squared. So then we also remember that our standard form looks like this: ax squared plus bx plus c equals 0. So this is important to remember because we have our c and our b both within this equation. So c is what we're solving for, and b is what we should know what that value is in order to solve for c. So our equation that we're going to be looking at today is x squared plus 6x plus 8 equals 0. So that's our equation we're looking at. We see that we do have a c value there already, but 8 is not a perfect square. We want c to be a perfect square. So in order for c to be a perfect square, it has to equal this. 8 is not a perfect square. So in order to find a number that is c, the number for c that is a perfect square, we're going to subtract 8 from both sides so that we can solve for that. So we're going to subtract 8 from both sides. We'll be left with x squared plus 6x equals negative 8. Now we see that we are missing our c value. We no longer have a c value here. This is gone. No c value there. So now we can solve for c. But before we do it mathematically, I'm going to show you how to incorporate algebra tiles in order to complete the square. So we're going to come over here. I like to use the CPM tiles because we use CPM as our textbook. So we're going to make this, because this is empty here. This is empty here. We have our equal sign, and this is empty over here. But we have x squared plus 6x. We have our equal sign, and we have negative 8. So over here, we're going to put x squared. We know there's just 1 because there's no coefficient in front of it. We have plus 6x, so we're going to add 6x tiles over here. I'm going to put this one down here so that they kind of look even. If you double tap it, it flips, which is pretty cool. And then over here on this side, we're going to bring over 8 tiles. If you tap it once, it turns negative. We want them all to be negative because we have a negative 8 on the other side. 2, 3, 4, 5, 6, 7, 8. Oops, 8. I'll make it look pretty. I like to keep them nice and neat just so it stays a little bit in order. Okay, so we're going to leave it like that. Now we see that right here, we're missing something. This is not a complete square because we're missing this entire thing. So that's what we need to solve for. This represents our c. So over here, if we go back over here, we need to use this equation here in order to solve for this value here, because we don't have a c anymore. We want to know what our c is. But we do see that we have our b value, right? We know our b is positive 6. We know our b is positive 6, so b equals 6. So if we know what our b value is, then we can solve for c. So we just go c equals parentheses 6 over 2 parentheses squared, because we know b over 2 parentheses squared is what our equation is to find c. So c equals 6 divided by 2, which is 3, squared. So c equals 3 times 3 is 9. So our c value should be 9. We do know that 9 is a perfect square. We know that 9 can be square rooted. So let's see if we add 9 tiles over here in our CPM algebra tiles. Let's see if we add 9 over here, if it'll make it a perfect square. So we're going to add 9 tiles, on this side because that's what our C value was. So before we test it out, we're going to add it over here and see if adding these 9 tiles makes it a perfect square, which it does. So we see that it completed the square in terms of the shape that we're given over here using our tiles. But we know that in order to, if we add 9 to this side, we must also add 9 to this side. So we're going to bring over 9 tiles on this side and see if see what we get. Okay. I'm going to leave them blue because they're positive this time since we're adding 9. And then we'll see what we get, 9. Okay. So I configured it like this so that we can kind of see that 1 minus 1, that equals 0. So those will cancel out. 1 minus 1, that equals 0 too. So that'll cancel out. We have 1 minus 1 here, 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1, and 1 minus 1. Those will all cancel each other out, so we'll get rid of those. Now we're left with just 1 positive 1. So we have our equation here, our perfect square equals positive 1. Now let's go back over here on this side and see if that works out for us mathematically. So I'm going to take this equation here, and I'm going to add 9 to both sides to this equation. So we have x squared plus 6x equals negative 8. I'm going to add 9 to both sides and see if it equals what we got over here on our algebra tiles. So then we get x squared plus 6x plus 9 equals negative 8 plus 9 is positive 1. And that, in fact, does represent what our tiles over here showed, which means this must be correct. So in order to factor this out now, since we have our perfect square, we know that the factors of 9 are 3 and 3. So we have 3 and 3, positive 3 and positive 3 because it's a positive 9. We know that our factors of x are x and x. I'm going to use the box method to show you guys how it looks exactly like what our algebra tiles look like. So if we were to factor this out, we know that x plus 3 and then x plus 3, right? Because x times x is x squared. Oops. X times 3 is 3x. 3 times x is 3x, and 3 times 3 is 9. If you were to add these together, you'd get positive 6x, which would give us this exact equation. Okay, and then when we look over here at our algebra tiles, we see that we have x squared, we have a 3x, we have x squared, we have 3x, and we have 9. Over here we have x squared, we have x squared, we have 3x, we have x squared, we have 3x, and then we have 9, which looks exactly like our box method. So what we could write above this here on this side of the algebra tiles would be x plus 3. And then we could write over here, because over here we have x plus 3, right? So then on this side over here, we could write x plus 3. X plus 3 on this side. So we have x, we would have x plus 3, which looks exactly like our box method, right? So now from this point on, we're going to solve now. We're going to solve for our x values. Since we know that our factoring out is x plus 3 times x plus 3. Another way to write x plus 3 times x plus 3 is just x plus 3 squared, which will equal 1 because we know that our equation equals 1. In order to get rid of this exponent, we need to square root it because this is x plus 3 squared. The inverse of squared is square root. So we're going to square root both sides. We get x plus 3, and the square root of 1 is plus or minus 1. So we see we have two different values here. We have a positive and a negative. So we're going to have x plus 3 equal positive 1 and x plus 3 equal negative 1. So we'll still end up with two different x values or two different zeros. In order to solve for x now, we must subtract 3 from both sides. And we get x equals 1 minus 3 equals negative 2. And then subtract 3 from both sides. X equals, these cancel out, these cancel out. Negative 1 minus 3 equals negative 4. So therefore, our x values, or our zeros, are negative 2 and negative 4. And that's your final answer. So this was a way to show you how to solve for for your how to complete the square and solve for your x values by completing the square using a brand new formula, which was this right here. C equals B over 2 squared. I hope that made a lot of sense and gave you another way to solve for quadratic equations.